G'day guys, you're back with MiracleMAX. Today in the workshop we have a Holden Captiva 2013 model 2.2 litre diesel with the dreaded P200A code in it. The $sign is not stuck on the dash, but that code is in there and it won't come out. What's wrong? Don't know. Let's have a look. I'll give you a little bit of background history on this vehicle. Recently I pulled off the DPF to get it cleaned. It was over 212% blocked. There was really an issue there. I've checked my pressure differential sensor and that worked fine. There's another video for that one. I've also checked the exhaust temperature sensor number 1, which is located at the turbo, and that appears to be okay as well. The G-Scan had a few little issues, but fortunately Ben Hansen of Mount Auto Equip was able to help me through that situation and put in a patch for me and get things back to square one once again. So what does this code represent and what can we do about it? What tests do we need to do? Naturally enough, before I start any job, I always do heaps of research. And not only have I looked up the code itself, the P200A, but I've also found a technical bulletin that should help us through the procedure. And also, not only that, I've found the location of the component in question, which is fantastic. It's a tight squeeze in there, guys, but we've got to find this component, sort out this issue, get the car back to the customer. The reason this vehicle came in to me the other day was because the check engine light was on, the DPF light was on, and also the power reduction light was on. That's the trifecta right there. At that point it had 3 codes within the system. One was a P2463, that was saying the diesel particulate filter was full, soot accumulation. A 242F00, which refers to, once again, over accumulation of soot. And the one that we're looking at today is a P200A, which is an intake manifold runner control valve circuit performance issue, blah, 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 etc. So that's the one. I'm not worried about the other ones for 2 reasons. First of all, the soot accumulation is as a result of this control valve not working. And once I cleared those codes and reset a few things, I was able to take it and do a service regeneration. A service regeneration is when the light comes on the dash, the diesel particulate filter light comes on the dash, you're able to drive it then for a certain amount of time, and then eventually the diesel particulate will come back to 0% of soot. In other words, it goes through a regeneration process as you drive. It's not a forced regeneration as what we would do with the scan tool, but at that particular time the customer had tried to do it, but it wasn't successful. But as soon as I cleared the codes, I was able to do that regeneration and it worked out well. So now we're looking at about 0 to 1% soot accumulation, just as a matter of course. But unless I fix this control solenoid, that issue will come back. So we need to figure out what is going on. To make matters worse, I couldn't find the fault code listed under Captiva 57, which is what this particular model is, under the 2.2 litre diesel. In fact, what I had to do, which is what Ben suggested, was go back to the earlier model, Captiva under diesel engine, and then there was the fault code, the P200A. So it's understandable that I couldn't find the thing originally, didn't bring on the $sign on the dash, the check engine light, and also the fault code wasn't under the model where it was meant to be. It was under an earlier model. Very confusing. Anyway, I've been able to identify that particular fault code. Now we just need to dig into the engine and find the damn thing. Trust me, these engines are tight as, mate. I'm going to give you guys the links to these bits of information that I have in front of me on the screen. This one is through AutoCats. It gives you, I know it's related to the Cruise, but the basic information is the same motor, I believe. So it gives us the fault code on the P200A, and it's quite detailed. It gives us the conditions for the fault code. It gives us testing procedures. It also tells us how to test the actual system using your scan tool to provide verification, which I'll do shortly. And not only that, it's got, even down the bottom here, it's got how to replace it. Now I believe this part may be in the different spot compared to that, but over here is another link that I've found which gives us the complete technical bulletin with regard to that. It's the 2.2 litre down here, as you can see, and it shows us a pretty little picture. Now I believe the one that we're looking at is this one here, the air tuning. It's what they call air tuning vacuum control solenoid. In the scan tool it's listed as an intake manifold runner control valve solenoid, I assume. So anyway, that's the procedure that we're going to look at. Get this thing up and running, complete with a regeneration process that works consistently. I think we'll start with the other page first, as that gives us use of the scan tool to see what our feedback is, if that's within parameters. So to be quite honest, I'm not exactly sure what we're looking at the moment, but we should see some sort of change. Our valve position sensor should change in correspondence to the valve control. We're seeing that come down. This should come down as well, I believe. It's just a valve position sensor, so it should record what we're actually doing. The command itself doesn't appear to be doing too much difference, but we are seeing response there. But I suppose the best thing we can do is just do manual testing at this point. First things first, we need to remove the engine cover. Now this fella hides all the goodies that we need to look at, and not only that, it hides the mess beneath. So we gently, they're held in by little locators with balls on the top, and we get that out the road. Have a look at that mess, hey? According to our technical bulletin that I have in front of me, you can see that it has several solenoids, 1, 2, an actuator, another actuator, a couple of solenoids here, possibly the ones that we're looking at. So this should be up behind the inlet manifold, which is way down there somewhere. The one in question, as I mentioned, is behind the inlet manifold. So this is looking at the back of the motor, and this solenoid is directly bolted to the back of the inlet manifold, which has our intake runner assembly in through there, and it just turns it on a pivot. Looking at the data relating to what they call after exhaust treatment, you can see here the exhaust gas temperatures are very similar, sort of. Don't worry about that centre bloke, he doesn't belong there. But these exhaust gas temperatures as you drive will get closer and closer. The front one's stuck in the turbo, the other one's stuck in the DPF, so you will get a variation between the two. That will indicate if there is in fact a blockage, or give you some information. A differential pressure is at 0, which is awesome. Our soot accumulation is at 0, so I'm happy with those results. Can't see any major issues there. If we have a look at the intake system now, these two numbers here are what we're looking at. You can see they're very similar, and that's how they should be. We're seeing the graph, same sort of description, but there's a couple of things I'm concerned about. So our desired boost pressure and our boost pressure should be the same, but we're clearly seeing a difference here, aren't we? So the sensor is saying 99 kilopascals and this one's saying 136. So there is a difference there. So we'll have a look at that sensor and see what it's doing. So to give you guys an idea of what I'm looking for is way up there, that solenoid about there somewhere. My finger's pointing in the right direction. That's not the fella that we're looking at the moment, but there's another one. It's got an accumulator that it goes to. One over this side. Oh, look, honestly, I don't know if I can actually show you or not. It's just behind there somewhere. It looks the same as that one. Probably all the same sort of actuator, I assume. But yeah, it's tucked away in there, man. That's just insane. Gotta be a contortionist to get to, but that's what I'm looking for. Got to get the hose off of that one. Maybe able to stick my hand down with a mirror, maybe some smoke as well. Smoke and mirrors from the top. See how we go. After much blood, sweat and tears, I've managed to test both of these solenoids with my multimeter, and they both measured 16 ohm. I don't believe that they're faulty. I believe that might be a carbon buildup that's creating an issue, which is quite common on a common rail diesel, particularly one that hasn't been maintained so well before these particular customers bought it. So look, I think I've got to pull this fella off and have a little bo peep what's going on inside, and then feel if the flaps are moving easily, and I suppose after that point we've got to start searching for carbon, because this will probably happen again unless we do a big cleanup, most likely. But anyway, the vacuum seems to be operating and all that sort of stuff. So what I'll do is I'll pop this off. I know that internally it's okay. I've done my resistance checks on both of them, 16 ohm. So I'll pop this off and see if it physically moves when I actuate it. Just to prove the concept that the control side of things is working, I have the G-scan in actuations, intake manifold runner control valve, and over here I have my incandescent test light. All we need to do now is select it and we can go through a range. Just keep an eye on that test light in the background. As we come up, it should in fact get brighter and brighter. There we go. You see that? We'll get brighter, 92%, 95%, I think that's the end of its travel, yes. And then we can just come down and down and down. That proves that the control side of things is working okay. We're down to 0% and that should cancel and should turn off in a sec. There we go. Job's done. Control side is okay. Look, I believe that it is carbon buildup in the inlet manifold, probably causing the intake runner, the swirl flaps, whatever you want to call the things, to drag, and that of course will bring on P200A, which I believe is as a result of carbon buildup, which in turn is as a result of lack of maintenance by the previous owner. So I've just got back from a road test. You can see I did 18 Ks in that road test. I'm happy with the differential pressure sensor. It's reading 0, soot accumulation 5%, that's okay at this point in time. 100 or 200 C compared to 180 exhaust gas temperature, so they're within QE of one another. Fairly happy with those results. Let's just escape out of there and see what the turbo's doing. And what do we have here? The desired and what we need there should be identical. There we go. 76, 78, 75, 74. It's really within QE of one another, isn't it? And up here the desired boost pressure and the boost pressure sensor isn't too far out. Let's see what fault codes are shown. And we've got no fault codes there. Now this is what I had before. No fault code was shown. So what you had to do was go out of the 5.7 Captiva, as you can see up there. You had to go up to where it says Captiva, enter on that, down to powertrain, engine diesel, and we'll check the fault code there. And that P200A is still there. I've spoken to others that said this code has come up and it's performing okay, and it's just a code that does come up, but I'm not thoroughly convinced, so I'll have to investigate that further. I've asked the customer to come back after they've used their vehicle for some time. In fact, they've done 1,300 kilometres. So I've hooked up my scan tool, just my little C reader, my launch C reader, and it's come up with the P200A. I'm not overly concerned about this code right now because I actually left this and didn't clear it last time on purpose. I'll clear it shortly using the G-scan because I want to see if there's any freeze frame data and also if there's any other PIDs or live data that we can look at that will help us to try and diagnose what the fault is. What about the OBD2 side of things? Now that should come up because my little C reader, which is basically an OBD2 reader, has come up with that. Diagnostic trouble codes, and there is our P200A. Let's head under the bonnet and see if we can have a look at that actuator. Who here doesn't like a new tool? Well, come on, put your hand up. We all love a new tool. I've bought myself a Medivac, and this is the Elite kit, not because I feel that I'm elite, but simply because it has a few more bells and whistles than the base kit. A lot of fittings over here. You know, it's used for not just vacuum but also pressure as well. So I'm going to be putting this bad boy to use on the actuator that I have now found. I'd like to give a bit of a shout out to Clinton Brett of Diesel Help Australia. He was kind enough to help me out with a little bit of diagnosis. He remembered one particular customer that he dealt with that had the same problem. Was able to take some photos, which is fantastic, of the inlet manifold when it was pulled off. This is the actuator in question that we've been looking for. Has vacuum attached to it, has a sensor of some description, possibly a position sensor, to gauge where the runner itself is. All the runner is, or swirl flaps sometimes they call them, is a big rod that goes all the way through the inlet manifold, and it has little flaps on it so that it can close over and it can create a higher amount of airflow or less amount of airflow depending on the requirements of the ECU at the time. There's another photo as well, and you can see the actuator on the top there. So where is it on our vehicle? Let's have a look. So let's do a bit of search and rescue. Come out wherever you are. There's the fella right there. That's the bloke that we're looking for. So the vacuum port is here down the bottom and the sensor is up the top. Like I said, I believe this might be a position sensor. So I'll get the G-scan and see what we can find. I might put vacuum here and see what it reads with the position sensor on the G-scan. I'll put a link down below with reference to testing the exhaust temperature sensor on this particular Captiva, but here's the information in front of me right now. And as I mentioned, if you disconnect the exhaust temperature sensor to be tested, and the parameter for that sensor should be 900 degrees. Now that's what we're reading on the G-scan, but remember we've had some trouble with the G-scan, so what I'm going to do is clear that code, and then I'm going to go back into my 5.7 Captiva. That's where the data made sense, and we'll have a look at it there. As I've already mentioned, it's so easy to get caught out by data if it's incorrect. Now remember, as I said, there are 3 exhaust gas temperatures, 1, 2, 3. Now the only ones that we need to pay attention to are number 1, which is up the top, 28 degrees, the one down the bottom, 32 degrees. Now they are the important ones. They're the only ones that really need to be paid attention to. We can see our last regen was done 1350 ago, which is pretty much what I said. And the good point is last time the regen was done was 243 kilometres ago. Excellent. So our soot accumulation is 42%, but that's okay. Once that comes up, it'll kick in for another regen. A differential pressure sensor is saying that it's 0 kilopascals. That makes sense. There's some good data there. Alright, so look, I'm not overly concerned about this exhaust temperature sensor data that I'm getting. It should be roughly ambient temperature, and yeah, it's pretty much 28 to 32 degrees. It's all good. So let's see if we can actuate this thing and watch it physically, and also operate it with the MiniVac and see if we can get a position sensor movement of that actuator. Look, I believe we're coming to the pointy end of our diagnosis here, and I think I've almost got it sorted. It's amazing, you know, every time I do a repair or a diagnosis, I'm amazed at how little I know. But it's because of organisations like TAT, the Automotive Technician, Clinton Brett at Diesel Help Australia, that help me through these processes. And that's why I want to pass it on to you guys. We need to make the complex simple. So what have I found? Well, as I said, this is an actuator. Basically, it's a diaphragm with a spring and a plunger on it. And that actuator is attached to our intake runner, which has those swirl flaps on it that move backwards and forwards like that. Now, just keep in mind, simple actuator, what should it have? Thanks to the purchase of my wonderful MiniVac, I can apply vacuum to it, and let's just see what it does. If we have a look down there, it's a little bit hard to see for you guys probably. Now that's the actuator rod. I'll highlight it for you. Just watch and see if it moves. I'm now applying vacuum to it, and that shaft should move up. You see it moving up there? And when I release the vacuum, and it's holding vacuum, I have no trouble with the diaphragm being split or anything. Just about to release the vacuum. Did you see that move down? So obviously the actuator is working okay. How does that compare to what we see on the G-scan? Is the position sensor working correctly? Let's have a look at that. Just about to apply vacuum to it. Here we go, there's the vacuum. And we can see that it's moving. So the sensor is reading correct. Now obviously we're not getting flow because the vehicle has not got any command given to it, etc. But we know that the sensor is reading all right. Let's release that. And that drops down nicely. Okay, so we know that the sensor is all right. Perhaps we just need to go for a road test and see what it's reading under load, etc. According to the data that's in front of me right now, everything appears to be working correctly. Even the valve position. Have a look at this. Okay, so we can see it's moving there. We're getting a command. Our command is over here, 20%, 15%. They should basically mimic one another. So we can see that all the operations are working correctly at this particular point in time, including our command, our ECU command. With that information in front of me, I can readjust my thinking as to what's necessary for this particular vehicle. These common rail diesels are very susceptible to carbon buildup, if maintenance is not carried out properly, if the incorrect oil is used, if the incorrect fuel is used, other factors come into mind that will just build up carbon, so much so that there will be restrictions in the intake manifold, the swirl flaps won't move or the intake runner won't move, it will get seized into place, and eventually you'll lose power, it'll go into limp home mode, etc. So the main problem with this particular vehicle is carbon buildup. And unfortunately, the people that bought this vehicle have bought something that has had issues beforehand, perhaps due to lack of maintenance, whatever the case may be. But we're going to see a DPF continue to block up as a result of this soot accumulation where the swirl flaps are not moving. One thing that I'm going to do before I close off is erase this particular code. I know what the fault is, I've examined it, so I'm happy to erase it. I've also recorded it and the freeze frame data. As they say in the reality shows, this has been such a journey, and it's true, this particular vehicle has thrown some curly ones at me, that's for sure. So what brought up this P200A? Well, I believe it could be carbon buildup. These common rail diesels are notorious for carbon buildup, and I believe that that might be the problem in this particular case. Even though our actuators are working correctly, our solenoids are working correctly, we can hear the runner itself moving, and also the G-scan has provided all that data for us to see that all the commands and the actuations are working correctly. Will this P200A come back again? Honestly, I don't know. If this carbon continues to build up, I believe that the intake manifold will need to be pulled off at some point and cleaned. This is not an unusual situation, it's fairly common. In this particular model, to access the inlet manifold, I've been told that the engine may need to come out. What were they thinking? Who knows? I may or may not get that job depending on what happens. But for now, I've cleared the code, the P200A. I've taken it for a really good road test. I've used my G-scan during the road test to look at data and make sure that everything was working okay. I'm happy with the results for now. I've learnt so much with this particular vehicle. Thank you very much for purchasing this vehicle, customer, because it has helped me to increase my diagnostic skills. Cheers for that. It's been a long-winded process with many a curveball thrown at me, that's for sure. Scan tool issues, temperature sensors that didn't read properly, and a battery in my light that just went flat. Great. I hope you enjoyed the video, guys. If you did and you haven't subscribed to my channel, please do so. Give it a like and feel free to comment down below. Oi, don't forget about that notification bell. You don't want to miss any future videos. So until next time, guys, this is MiracleMAX signing off. I will catch you later.